Yeah, good evening. This is Mahesh Reddy, and today we are discussing about the concept called logic gates. Logic gates. Coming to the logic gates are fundamental basic building blocks of your digital circuits. So, digital gates are the basic building blocks. So, first point, digital logic gates are the basic building blocks. So important point. And then next, coming to logic gates are classified into three types. Logic gates are classified into three types. So what are the three types? First one is basic gates. The another name of basic gates is called standard gates. Okay, what are the standard gates? And or not. So these are the three basic gates, and the basic gates are also called as standard gates. Here you have to remember always while you mentioning gates in capital letters. Always here you have to mention in capital letters. Next, second one is universal gates. What are the universal gates and how many universal gates means? Only two gates, NAND, NOR. NAND and NOR are the universal gates. Why we are calling as NAND and NOR are universal gates means with the help of NAND and NOR we can design the basic gates and or not. Not only this and or not, we can also design special gates. So there is one more classification called special gates. So here logic gates are mainly classified into basic gates. Basic gates, another name is called standard gates. In that basic gates, once again, AND gate, OR gate, NOT gate. Universal gates, second one is universal gates. In this universal gates, NAND and NOR universal gates. Next, special gates. So what are the special gates? Special gates are again classified into two types. One is XOR and XNOR. Some textbooks they are going to be mentioning XOR. This is also representation XNOR. Both indicate same meaning. XNOR, XR. See, this representation and this representation both are equal. And here also XNOR, XNOR. Right. So next, coming to here, we will discuss about the functionality of the gates. Functionality to standard gates or basic gates, standard gates. Now we will discuss about one by one what is the logic representation, logic diagram, and truth table and functionality. See here, standard gates. First gate is AND gate. Coming to AND gate, so this is the AND gate. So AND gate symbol, the representation, this is called logic symbol. So here the symbol is, they are going to be represented in this manner. So this is the symbol, and here we are taking A and B are the inputs and Y is the output. A and B are the inputs. So this side we are representing inputs, and this side we are representing outputs. Right. So here the functionality. So this is the logic diagram, logic symbol of the AND gate. And coming to function, what is the function means? Output is given by A into B. In this AND gate, it is always the product of A and B. It's always product of A and B. Coming to the truth table. What is by truth table? What it consists generally? So truth table is it consisting of two parts. One is inputs, another is output. Inputs and outputs. Here in the case of gates, in this standard gates, here A and B are the inputs. For two inputs, here important point, for two inputs, the maximum combinations possible, here we have to write possible maximum combinations is given by formula 2 power n. So 2 power n means here 2 inputs, right? For 2 inputs, 2 power 2 is 4 possible combinations. So what are the 4 possible combinations? Here you have to write A and B, and output is y is equal to A into B. And what are the possible combination means 0 0, 0 1, 1 0, 1 1. So these are the 4 possible combinations. For this 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. So this is your gate, that is AND gate functionality explained in truth table. So AND gate logic symbol, and this side we are considering inputs, and this side we are considering the outputs, and the function output is given by y equal to A into B. For two inputs, the maximum possible combination is given by 2 power n. So this is the important formula, 2 power n. So here we are taking 2 inputs, right? So 2 power 2 is totally 4 possible combinations. What are the 4 possible combinations? First one 0 0, next 0 1, 1 0, 1 1. And here these are the possible combinations. From this possible combination 0 into 0 output function y is equal to A into B, right? So in this A into B, 0 into 0 is 0, 0 into 1 is 0, again 1 into 0 is 0, and again 1 into 1 is 1. So this is the AND gate. Next coming to here, next gate is OR gate. So OR gate. So in this OR gate, the logic symbol, the representation of this OR gate, there is a small curves, the representation. You have to clearly differentiate between AND gate and OR gate. So here A and B, once again we are considering A and B are the inputs, and y is equal to output function is given by A plus B. That is the output. So here this is your OR gate logic symbol, and the truth table. Next coming to truth table of this OR gate. See, in this truth table I am directly mentioning A, B, output y is equal to A plus B. Here we are considering 2 inputs, right? Maximum combinations are 4 combinations, 0 0, 0 1, 1 0, 1 1. And here y is equal to A plus B, right? So due to that purpose 0 plus 0 is 0, 0 plus 1 is 1, and again 1 plus 0 is 1, 1 plus 1 is 1. So here you have to remember, so this is your truth table of your OR gate. So one is AND gate, second one is OR gate, and truth table. There is one more gate called NOT gate. So here the NOT gate, another name is called inverter. NOT gate, another name is inverter. Coming to here logic diagram. So here this is the representation, small triangle, and triangle having bubble. So always most of the students are forgetting this bubble. This bubble is very important. If without bubble we are calling as buffer. Okay, anyway, this input, this having only one input. If you are giving input is A, output we are getting A bar. That is complement of the input. That is the reason we are calling as the another name we are calling as inverter. NOT gate, another name is inverter. So here in this truth table, so very simple truth table, because of only one element, maximum combination is 2 combinations. One is A. If you are giving A, the output we are getting A bar. If you are giving A bar is input, we are getting y is equal to A. So that means in terms of zeros and ones, if you are giving 0 input, we are getting output is 1, and if you are giving 1 input, we are getting the 0. So this is the operation of your NOT gate. These are the standard gates. Thank you. Next video we will explain about the universal gates.